1, and we're live. We're beginning a new unit on dividing. And in fact, I have one more slide before this to show you what our unit would look like. This is what our unit's going to look like. We're going to be working on division by 1-digit divisors. And we have about 7 lessons in here, and we're going to be looking at standard procedures for division and why they work. Okay, I know with multiplication we had a lot of other procedures that we use, but for division we're going to be focusing on just the standard algorithm. So our first lesson is dividing by multiples of 10 and 100. Does this look familiar, guys?
Yeah, from 4th grade.
From 4th grade? So it should look double familiar because we also just did multiplying by multiples of 10 and 100 in our previous chapter. So we're going to see, and I want you to pay attention for similar tricks. Does everybody remember how we multiplied by multiples of 10 and 100? Anybody want to say quickly what the steps were? I'm looking for a hand. I'm looking for Lucy, thank you. What were the steps?
Well, I wasn't raising my hand, but I'll still answer, okay?
Why,
so
thank
this
you.
is what I think it was. So, first we do like 10 of, I don't know, we just something, so we have the 10 and then we have the 100, but then we pretend the zeros aren't there in the 100 or something, and then we do 10 divided by 1, I don't know, and then we add the zeros.
Right. No, I see that you have the steps there. It's probably easier when you're actually doing it, right, than explaining it. Sometimes that's where the tricky part is. But we're going to look at it again, so don't worry.
Wait,
Thank you for
explain it.
I'm looking. Who do we got? Who was that? State your name.
It's Dominic.
Oh, Dominic, go ahead. Go for it.
Okay, so mental math. So multiples of 10 and 100. So you can use it in mental math, like maybe for example, maybe like 50 times 10 or something, or like 50 times 100. Hundreds of tens are easy to do in mental math because if you multiply something by 10, you just have to put that number and put how much digits of that zero of the number with the zeros you're adding. Like for example, like 5 times 100, you put the 5, take the 1 out, put a 5, and then put the 2 zeros and the 100 in there.
Beautiful. That's exactly it. And we're going to see something not identical, but very similar in the steps for division. Thank you very much, Dominic and Lucy, for giving that a shot. All right, so how can you use mental math to divide multiples of 10 and 100? Let's take a look at some terms that we're going to be using in this chapter, and actually in the next chapter and for life. For our division, these are the terms that you should know. Now remember, with multiplication, we had a factor times a factor equals a product. In division, we don't necessarily have 2 factors because with factors, you can switch the order around, right? That's why they have the same name. It's a factor and a factor. With dividends and divisors in division, we can't swap the order. So a dividend is the number that is being divided. The divisor is the number that divides into the dividend. And the product, oops, sorry, I left up my old definitions. The quotient, please, Paul, I'm going to actually fix that now because it's going to bug me. The quotient is the result of dividing. I'll show you a picture. So if we were to write it horizontally, we would say our dividend is being divided by our divisor, which equals our quotient. And sometimes you have a remainder if it doesn't divide evenly. If we were to write out our division problem using our standard algorithm, which we'll focus on this week, our dividend would go inside of the house, and our divisor would go outside of the house, and our quotient would go up on top. All right? So we're going to be trying to use those words consciously so that we practice using proper math vocabulary. All right, we've got our problem solving for today. Patrick, you made the cut for this week's word problem. I'm looking for Patrick out there. There you are. All right, Patrick. Patrick is DJing for the Bay Area Virtual Distance Festival on Twitch. He will be live streaming with an exclusive new set from our very own School of the Madeline for this 3-day event. If 24,000 people have registered to attend the event, and the same number went each day, how many people attended each day? So that's a very wordy problem. Let's break it down. We have a lot of extra information here, right, about Patrick and his upcoming event, Rising Star Patrick. Who knew? Huge DJ out here. But what are some of the key things we need to know? Well, we need to know how long this event is, and the question's asking how many people attended each day. So in this problem, it says if 24,000 people registered to attend the event, so that's how many people have purchased tickets or e-tickets, they've registered, and the same number went each day. We have 3 days that we're going. How many people went each day? On your whiteboards, write down how you think you would solve this problem. You don't have to solve it just yet. I just want to see what your equation would look like. So whiteboards are up when you've got your equation set. All right, Julian's quick. Good job, Julian. Oh, I saw another one. Kai solved it. Way to go. Clarissa's got it. Good. I see a variation too. Some people are writing it horizontally. Some people are writing it using the standard algorithm. Good. Jordan's got it. Quinn's got it. Ashley's got it. Zoe's got it. All right, Soren gave it a shot. Everyone should be trying. Donovan's got it. Oh, Donovan's got a whole, I'm trying to see in your window, I'm sorry. Donovan gave it a shot. Seraphin's got a whole equation down. Lenny's got it. Emma's got it. All right, so I know that our brain is trained with multiplication, but believe it or not, even though we've got some similar clue words, this actually is a division problem. We're taking those 24,000 people, that's how many people are attending this event in total. And then we still have 3 days. So because we are splitting up those 24,000 people into 3 days, and because we have an equal amount, see where it says the same number went each day. Whenever you are making equal groups of people, that word same number each day, the fact that we are splitting up these people, making equal groups, we're always using division. So we're going to be taking those 24,000 people and dividing it into 3 days. Yes.
You can check it by doing multiplication.
You can definitely check it by doing multiplication. Those two, right, those two operations are called inverse operations because they can actually be checked using each other, and they could be undone using each other. All right, so now that we've focused on why this is a division problem, is there anyone that doesn't understand why we're not multiplying, right? We're not trying to see, we don't have 24,000 people each day. We have 24,000 people all together. And then we're taking those 24,000 people and we're splitting them. Some of them are going into day 1. Some of them are going into day 2. Some of them are going into day 3. And the problem even told us that the same exact number is going into each day. So we want to split up those 24,000 people into those 3 days so we can figure out how many people are going on just one day. So let's set up our equation. All right, 24,000 divided by 3. Our first step, just like with our multiplication, is to solve our basic facts. And I think that Lucy and Dominic were trying to say this. What are our basic facts in this equation?
3 and 24.
24 and 3.
Correct, 24 and 3, because we know that 24 is in the 3 times table. So I'm going to highlight my basic facts. 24 divided by 3. Now we want to ask ourselves, how many times can 3 go into 24? How many times?
8.
Use your 3 times.
8.
Oh, Jaden's quick on it. That's right, 8.
8.
3 goes into 24 8 times. All right, next step. Count your additional zeros in the dividend. For those that forgot what the dividend is, remember the dividend is always the number that's being divided. So the 24,000 is our dividend.
That's right.
How many
Sounds
zeros
like
are
it's
there?
Divided.
Right.
3.
3. Let's count. 1, 2,
3.
3. And guess what?
Is a magic.
Now that we've counted that there are 3 zeros, we have no extra zeros in our divisor. We can start to solve. We're going to annex, which just means to add on the zeros in our quotient, which is our answer. So take those 3 zeros and we've added them on to our quotient, making our final answer 8,000. Who sees a similar pattern here with our multiplication?
Because 3 times 8,000 equals 24,000, but it's just repeated subtraction.
Exactly. Instead of repeated addition, it's repeated subtraction. If you were to use your inverse operation and multiply 8,000 times 3, you would get 24,000. So do you see how it's the same steps as our multiplication? We found our basic facts, or we boxed our basic facts, counted our zeros, and put it into our quotient. Just instead of multiplying, we divided. Same thing, right? Anyone confused by our steps here? We found our basic facts? Okay. I'm going to pause right here. I'm gonna word. Okay. So here we go. All right, so for Patrick, way to go, Patrick, 8,000 people would attend the virtual Dis Dance Festival to listen to Patrick's set. So that would be 8,000 on day 1, 8,000 on day 2, 8,000 on day 3. 8,000 times those 3 days gives us those original 24,000 people, right? 8, 16, 24, add on those zeros, and we've got 24,000. You've got quite a crowd joining you, Patrick, on that virtual festival.
How can you be famous?
Yeah, you've got to be pretty famous to have that many people. All right, guys, so I want to look at, I have a little bonus question to go along with that, but we'll look at it at the end. I'm going to stop sharing temporarily, and I want everyone to join me on page 92 and 93.
92 and 93?
92 and 93.
Are you were going to do crochet?
All right. So let's, happy Monday. Okay, I'm gonna erase this.
Happy Mondays.
540. I'm looking at number 1 divided by 9. Our first step is to box our basic facts. Box our basic facts. Our basic facts here are what? Think of the times tables you know. What are our basic facts in this equation?
4 and 9.
54
4 and 9.
divided by 9. 54 divided by 9, or you could say 9 times what equals 54? How many times will 9 go into 54? How many times? 9.
6.
6. 9 times 6 is 54. So I'm going to put 6 in my box. And my second step is to
Add the 0.
count my zeros.
Wait, what page are we on? Which is 1. So you put the 0.
We're
1
in-
0.
We're on page 92 and 93. We have 1 0. We put 1 0 down. And our final answer, what's our final answer called in division?
Quotient.
A quotient. Our quotient is 60. So we have a dividend divided by a divisor equals the quotient of 60. Voila. Let's try another one. Pretty simple, right? When after we did it with multiplication, it's like the same, except we're dividing now. All right, 490 divided by 7. Again, box your basic facts. What's our basic facts?
49 divided by 7.
Thank you. 49 divided by 7.
What's 7?
Let's solve it. How many times does 7 go into 49?
Wait, what question are we on?
7.
Oh, number 2. Yes, 7. 47 goes into 49 7 times because 7 times 7 is 49. Again, these are very easy if, big if, you know your times tables. All right. And count your zeros in your dividend. 1 0 in my dividend, 1 0 in my quotient.
Divided by 7.
Okay, cool.
Okay.
Before you. Hooray.
Pretty simple, huh? You guys got that?
Yeah.
By the way, a trick to remember your dividend, divisor, and quotient is dividend, literally has more letters in it than divisor. So the dividend is longer than a divisor.
Wow.
Right? And then you get a quotient. That one you just have to remember. That's the only one that's different.
One of the reasons why it's called the
divisor.
divisor because it seems like it's the divider. It seems like
Right.
like
It's the one that's being
divider.
divided into. Yes. All right. Let's try another one. Dividend, divisor, quotient.
QQ.
Quotient.
28,000 divided by 4. All right. First step, box your basic facts. What are my basic facts?
4 and 28.
28.
28 divided by 4. Awesome sauce. Let's divide now. How many times does 4 go into 28? Got to know your times tables here.
7.
7. Lucky number 7. All right. Final step. Count your zeros in your dividend. 1, 2, 3. 1, 2, 3.
Are you speaking another language?
What do you
Perhaps.
I have no idea what you're saying.
That sounds like French. I don't know if it's French, but it sounds like French. I don't know.
So our final answer is 7,000. You can. Yes.
Million.
What was that, million? And you can check it. You can check it, guys, by doing the inverse, right? 7,000 times 4 will give you 28,000. Okay. Pretty simple, huh?
Yep.
All right, let's try.
1, 2, 3, 4.
Are there no like? Well, I guess there's not. They're all pretty much this easy. Unless you unless you need to brush up on your times tables, because then you're like, wait, what? All right, what's the first step? Box your
Basic facts.
48 and 6 are the
48 divided by 6. How many times does 6 go into 48?
8.
times.
8 times.
And then you add the 3 zeros.
Woot woot. 1, 2, 3. 1, 2, 3. Our final quotient is 8,000.
1,000 million.
Stop with that.
Yeah.
8,000 million.
Okay.
Stop.
All right, guys. Try another one because I know that these are getting difficult for you.
No, they're not. They're really easy for us.
These are getting so difficult, guys.
We know these by heart.
In your head.
I know. This one got even tougher.
Yeah.
I hope you guys can manage. I know. I'm really stressing you out on a Monday, huh?
Yeah. No, you're
This
not.
is a very stressful Monday, guys. I'm so sorry.
Answer 6.
I'm torturing you. All right. What's our first steps?
Basic facts. 36 and 6.
Box your basic facts. You guys know how to do this, right?
Are
Make
you
a
talking a
box.
picture?
It's a
Your
box.
basic facts. No, it's a picture.
Box your basic facts.
It's the frame of a picture.
What's my basic facts?
36 and 6.
36 divided by 6. Okay, some of us are just making noise for the purpose of making noise and not contributing. All right. What's 36 divided by 6? How many times can 6 go into 6?
6.
Plus
0
equals 60.
Count, guys, count the extra zeros in your dividend and add it on to your answer.
That was so
60.
stressful.
I know, very stressful, very stressful. All right, one more because, you know, I'm tortured.
Just for the
I'm
heck of
torturing
it.
you.
Just for the heck of it.
9,000.
Already done 6.
Let's do 1 million times 1 divided by 7.
All right, what's our first step?
Box
your basic facts.
Box your basic facts. What are they? 81 and 9. Okay. 81 divided by 9 is?
9.
9,000.
All right.
Put the 3 zeros in there.
3 zeros.
9,000.
Voila!
9,000.
9,000. Don't forget your comma. 1, 2, 3, comma.
You're not
1, 2, 3, 7.
All right. So, is there anyone that doesn't get how to do this?
no.
Nope.
Yes, that's okay, Willow. I want to show you one thing because there was a very specific, and I'm going to just go back to my examples. There was a very specific, maybe I can jump to my rule slide really fast. Notice the rule here. It's something slightly different in our division than our multiplication. It says count the additional zeros. We didn't see that with multiplication. I just want to show you quickly. You don't have to do this just yet. This will be in our next chapter, but I just want to show you, what if the festival was a month long and we were splitting those 24,000 people into 30 days instead of 3 days? So look here. I just want you to watch up. Oh, some of you know how to do it already? Okay, so look, we still would do look at our basic facts, right? We would still do 24 divided by 3. We did that in the last time, right? But here's the difference. You know when we're counting our zeros? We're only looking for additional zeros, meaning if
80,000.
there's zeros in your dividend and your divisor, additional zeros means, watch. So these zeros are not additional because there's a 0 in both places. So if there's a 0 in your dividend and your divisor, they cancel out. So the only 2 extra zeros, this is not an extra 0 because there's 1 in both places. The only 2 extra zeros here, 1, 2, get added on. 1, 2.
So only 800 people. Do
Only
it each day.
800. And that makes sense, doesn't it? Because you're not splitting it over 3 days anymore. You're splitting it over 30 days. So there's going to be less people going each day. Okay? So you wouldn't count these zeros because these zeros appear in both your dividend and your divisor. They are not additional zeros. Okay? They have a counterpart in each of our numbers. Okay?
Wait, if we were dividing it over 300 days, would you take away, like, cross out 2 zeros?
Exactly. Exactly. If as long as there's zeros on both sides, they cancel each other out until there's not any other zeros.
What about 30,000 people? There would only be 8 people going each day.
Well, it would actually be less. It would be less. It would be
only 4?
It would be like 0.8, but we'll get to that when we do decimals. Yeah.
Wait,
so
half of a person would be going.
It would be like a fraction of a person. Let's not get morbid here, guys. Okay. I think we're good. I think we got that. Let's see if you could do it. Truly do it mentally now.
Why?
Don't write it. Because that's the whole point. In your head.
That's the point.
That's the whole point, to do it in your head. Ready?
Yeah, but what
Ready?
about 1 million, 8 million?
Let's look at the ones on page 92.
Mm-hmm.
And I want you to hold up your answer on your board quickly. Ready?
29.
I want to see you do it in your head, meaning I should only see your answer on your board. Ready?
Number.
220 divided by 2.
Oh, wait, that's the number 1.
Jaden's got it. All right, Lila, I'm seeing some. All right, I think some of you wrote it out. You just had to use your basic facts. 22 and 2. 22 divided by 2 is 11. 1 0 to add on. All right, let's try another one. 6,300 divided by 9. 6,300 divided by 9. Find your basic facts in your head. Divide them. Count your zeros. 6,300. Think how many zeros are in that. Divided by 9. Sinjin, recount your zeros. 6,300 divided by 9. How many zeros do you have in your answer? Kai, rethink that. How many zeros do you have in your answer?
It's 700.
There are 2 zeros in the number 6,300, so your final quotient must have 2 zeros in it. Yes, Quinn, what's up?
I already did up to number 25 mentally.
Oh, well, awesome. All right, so the answer was 700 for those who got it. Let's try another one. 36,000 divided by 3. 36,000 divided by 3. Think how many zeros are in that. And then your basic facts. 36,000 divided by 3. You guys are fast. I love it. Great mental math. Count your zeros. All right, I'll let you, if you have to write it down so you can see how many zeros you can do it. 36,000 divided by 3. You guys are absolutely correct. It is 12,000. there are 3 zeros in 36,000. So some of us have left off a 0. I'm looking around. Some of us left off a 0.
Miss Velez,
It's
on the
kind of
one
hard,
before
right?
this
When
one,
it's in your head. Yes, what was that?
Miss Velez, on the one before this one, you said 6,300 divided by 9, right? The one before this
Yeah,
one?
6,300 divided by 9. Yes. So that has 2
So
zeros
the-
in it.
So you got it correct. Hi.
Yeah. Yeah. All right, and last one.
Uno.
Wait, Miss Velez,
Yes.
if it was 36, if it was 63, the one before this one was
It was
63,000?
6,000. No, it was
6,300.
6,300.
6,300
that's right,
divided by
okay.
9. Yeah. All
I
right,
did.
last one.
Okay.
Last one. 4,200 divided by 6. 4,200 divided by 6.
700.
Shh, don't. I'm looking at the boards. That's the whole point of the boards. I have you guys all up on one screen, so I can see everybody's answers at once. Sweet. That's right. 700 is the final quotient. All right. I think we're solid with this. Does anyone have any questions? You're not going to have any you're not going to have any divisors that are more than 1 digit yet, because this chapter, I know, you're like, I need that challenge. It's coming. This chapter is only dividing by 1 digit divisors. So you're not going to have divided by 10 or 20 or anything like that. That'll be in our next chapter.
Miss Velez?
So this chapter is a true test in your times tables. Even though it is a division chapter, you will not be able to progress with any of the lessons for our long division without having strong times tables. You need to know those.
Miss Velez,
Okay?
are
Yes.
we going to take like a test for math?
I'm going to pause here.